solve quiz 2 of unit 5 that says like this. 3 capacitors with capacitance C1 equal to 3.1 nanofarads. Capacitor 2 equal to 1.3 nanofarad. And capacitor 3 equal to 3.7 nanofarad are wired to a battery with a voltage equal to 14.9 volts as shown in the figure. What is the potential drop across capacitor C2? So in this one, the potential drop is equal to the voltage. So we are asked to obtain the voltage in the capacitor 2. So for obtaining this one, first we have to solve our series. Here we can notice that our capacitor 2 and our capacitor 3 are in parallel. So we have to sum them. So for capacitor 2 and capacitor 3, we have to sum them. 1.3 plus 3.7 is equal to 5 nanofarads. And then for obtaining the equilibrium of these two capacitors, we have to sum the inverse. So we will sum these 5 but in the inverse plus the inverse of our first capacitor, that is 1 over 3.1. And this is equal to 81 over 155. So for obtaining this is 1 over the capacitor in equilibrium. So for obtaining our capacitor in equilibrium, it's the inverse of our result. So it will be 155 over 81. So for obtaining our voltage, we have to obtain the relation. And the relation between these two is that the capacitor in equilibrium is equal to the charge over the voltage. So the charge will be equal to the capacitor in equilibrium times our voltage. So we know that our charge will be, for this part, will be equal to the charge in 2 plus the charge in 3. And as we know, the charge is equal to the capacitor times the voltage. So the capacitor in equilibrium times the voltage will be the capacitor of 2 times the voltage in 2 plus the capacitor 3 times the voltage in 3. But we know that the voltage in 2 plus the voltage in 3 are exactly the same because of the type of circuit we have. So once we know this, we can get to rewrite this expression by saying that the capacitor in equilibrium times our voltage is equal to our voltage 2 times our capacitor 2 plus our capacitor 3. And once we have this expression, we know this term, we know this term, we know this term, and we know this term, but we are looking for our voltage number 2. So we have to get this out of the expression, and then we can substitute our values. So if we get the voltage 2 out of the expression, we get to obtain the voltage 2. It's equal to our capacitor of equilibrium times our voltage over the sum of the capacitor 2 times plus the capacitor 3. And once we have this, we only have to substitute our values, and we know that our capacitor in equilibrium is equal to 1.91. So here we will have 1.91 times our voltage, and we know that our voltage is 14.9 over our capacitor 2, that is 1.3 3 nanofarads plus our capacitor 3 that is 3.7, and we know that this is 5 nanofarads. And as we solve this operation, we will obtain that our voltage 2 or our drop across the capacitor 2 is equal to 5.7 volts. And this is how you solve this quiz.